Most people think wireless charging sends electricity through the air. It doesn't. The moment you place your phone onto a charging pad, an invisible engineering process begins. There are no exposed metal contacts, no physical connection, yet within milliseconds, energy starts flowing into your battery. So what is actually happening? Today, we're slowing time down to uncover every critical step inside a modern wireless charging system. Everything begins inside the charging pad. Although it looks simple from the outside, hidden beneath its surface is a carefully engineered power conversion circuit. Electrical energy first arrives from the wall adapter as direct current. But the transmitter coil cannot create the magnetic field needed for wireless charging using direct current alone. Before anything else can happen, the electricity must first be transformed. A high-frequency power inverter rapidly switches the incoming current thousands of times every second, converting direct current into high-frequency alternating current. This alternating current immediately flows through the transmitter coil, a precisely wound copper coil designed specifically for efficient energy transfer. As the alternating current races through the transmitter coil, it continuously creates and collapses a magnetic field above the charging pad. Although completely invisible, this changing magnetic field is now carrying energy. Unlike a charging cable, no electrons ever leave the charging pad and travel into your phone. Instead, only magnetic energy crosses the small air gap between the two devices. Hidden beneath the back cover of the smartphone is another precisely engineered copper coil called the receiver coil. When the phone is placed correctly above the charger, the changing magnetic field passes directly through this coil. According to the principle of electromagnetic induction, the constantly changing magnetic field generates an entirely new electrical current inside the receiver coil itself. The electricity powering your phone is actually created inside the phone, not transferred directly from the charging pad. However, that newly generated electricity still isn't ready to charge the battery. The receiver coil produces alternating current, while a lithium-ion battery can only store stable direct current. To solve this problem, the electrical energy immediately enters a rectifier circuit. Here, alternating current is converted into smooth direct current that can safely power the rest of the charging system. The direct current then flows into the battery management system. This intelligent controller continuously monitors voltage, current, and temperature throughout the charging process. Hundreds of times every second, it decides exactly how much energy the battery can safely accept. Only after every operating condition has been verified does electrical power finally enter the lithium-ion battery, where it is converted into stored chemical energy. If you've ever noticed your phone becoming warm during wireless charging, there's a reason. Not every bit of magnetic energy successfully reaches the receiver coil. Some energy is naturally lost during transmission and becomes heat instead. Even a small gap between the coils, or a slight misalignment, reduces efficiency and increases heat generation. That's why wireless charging is usually slower and less efficient than charging with a cable. Modern wireless charging systems solve much of this problem using magnetic alignment. Inside both the charging pad and the smartphone is a precisely positioned magnetic ring. As the phone approaches the charger, the magnets automatically pull both coils into their optimal position. Better alignment allows more magnetic energy to reach the receiver coil, increasing efficiency while reducing unnecessary heat. Behind this entire process is another critical component: the key controller. Before delivering full charging power, the charger and the smartphone exchange information in just a few milliseconds. They verify compatibility, negotiate the appropriate power level, and continue communicating throughout the entire charging session. This constant feedback allows the system to remain fast, stable, and safe under changing conditions. Finally, the regulated electrical power reaches the smartphone mainboard, where it is distributed to the battery and every subsystem inside the device. From the outside, all you ever see is a small charging icon appearing on the screen. But underneath that simple animation, power electronics, Magnetic fields and intelligent control systems are working together with extraordinary precision. Wireless charging isn't about electricity magically traveling through the air. It's about transferring energy through a carefully controlled magnetic field, then rebuilding usable electrical power inside the phone itself. Every time you place your smartphone onto a charging pad, this invisible engineering process unfolds in just a fraction of a second, silently delivering energy without a single wire.